Hello everyone, I welcome you all to Startup Academy, India's exclusive coaching for ISS examination. In today's lecture, we'll be dealing with the new distribution, which is geometric distribution. Now, geometric distribution is the distribution which was derived for measuring the number of failures before we get one success. So it measures the number of failures before we get the first success in anything, in any case. Suppose we have the probability of success defined as P and the probability of failure of an event defined as Q. Suppose we have these two terms. Now we say that X follows geometric distribution GEOM with the parameter P. There is only one parameter because Q is dependent on the parameter P only. Q is nothing but equal to 1 minus P. So the PMF of this distribution of X can be represented as Q raised to the power X into P, where P lies between 0 and 1 and X has the values 0, 1, 2 up till so on till whatever the last term is. This PMF is useful for our calculations in this geometric distribution, where Q is the number of successes, number of failures before we get one success, which is P. Okay, P is success, and all the failures occurring before this first success is termed as this geometric distribution is all about Q raised to the power X, number of failures before we get one success. Now moving forward to the properties of this distribution. There are not many properties, some of them we'll be doing. The first property is mean. Mean of this distribution is Q upon P. Second property is variance. Variance of geometric distribution will be Q upon P square. Third property will be MGF. If we talk about MGF, then it will be P upon 1 minus Q e raised to the power T. This will be our MGF. If we talk about another property, which is the characteristic function, then it is denoted by phi xt and it is given as P upon 1 minus Q e raised to the power it. And the fifth property is probability generating function. And for this also you need to know the formula directly, or otherwise you will be just doing the summation and everything and you won't be able to do it within the limited time, and hence you will waste your time. So the PGF of this will be P upon 1 minus QT. Now here this MGF can also be written as P into 1 minus QET raised to the power minus 1. And similarly these two can also be written as P into 1 minus QT raised to the power minus 1, P into 1 minus QEIT raised to the power minus 1. Either way you can write them. So these were some of the properties of our geometric distribution. Let us see what the questions hold, and if there would be any new property, we'll talk about that there only. So this is just a normal statement based question. A biased coin is tossed repeatedly a number of times until a head turns up. The distribution of the number of tails. Here they have asked the number of tails, and we our probability of success is the head turns up, and number of tail will be Q. So the distribution of, they have asked us the distribution of the number of tails, which is the number of failures before the first success come, before the first head turns up. So this is nothing but our geometric distribution. That is how you see that in examination. Now moving forward to another question. Here they have given us that a random toss of a balanced die repeatedly and independently let x denote the number of tosses before the first 5 appears. Then probability of x equals to this. Now we have discussed that the PMF of x equals to x is nothing but q raised to the power x into p. Then probability of x raised to the power k, x is equals to k, should be equal to q raised to the power k into p. Now here that x denotes the number of tosses before the first 5 appears. That means that probability of success is 5 when 5 appears on the die. 5 appears how many times? 1 out of 6 times. The chances, the probability of appearing of 5 is 1 by 6. And probability that 5 does not appear is 1 minus 1 by 6, which will be 5 by 6. And substituting these values here, of q and p, we will be getting 5 by 6 whole raised to the power k into 1 by 6. This can also be written as 5 raised to the power k upon 6 raised to the power k, and one more 6 is there in the denominator, so we can add k plus 1 with the exponential terms, or with the laws of exponential. So this forms our option number D. They have asked us probability x is equals to k only, and this is how we attempt the question of uh, geometric distribution in the examination. Now the third question is the moment generating function of a geometric distribution with parameter p. Geometric distribution moment generating function is nothing but mgf. I've told you mgf is nothing but equal to p into 1 minus qet raised to the power minus 1, or it can also be written as p upon 1 minus qet. Now the option which matches is option number B, because here et is multiplied, so it is cancelled. Here the power is not minus 1, so it is cancelled. This matches our option. Now moving forward to fourth question, which is the moment generating function of a geometric distribution is given as. Now they have here directly given us the moment generating function. We know for a geometric distribution, the moment generating function is defined as p into 1 minus qet raised to the power minus 1. So they have given us equal to 5 minus 4et raised to the power minus 1 is equals to p 1 minus qet raised to the power minus 1. Now we can divide this whole equation by 5. So we will be getting 1 by 5 into 1 minus 4 by 5 et raised to the power minus 1, which is equals to p 1 minus q et raised to the power minus 1. Now on comparing these two, we get p is equals to 1 by 5. Since p is here and 1 by 5 is here, we can get them. Then 1 compared to 1, minus compared to minus, then in place of q here it is 4 by 5. So q is having the value 4 by 5. So we got both the values p and q, and then they have asked us the value of probability x is equals to 5 or 6. Whenever or is there, then we add them. Probability x is equals to 5 plus probability x equals to 6. Now in geometric distribution, probability x equals to x is nothing but q raised to the power x into p. And if we open this probability x is equals to 5, it will be q raised to the power 5 into p plus probability q raised to the power 6 into p. And if we take common terms outside, q raised to the power 5 into p, we will be left with 1 plus q. And replacing the values here, we'll be getting q raised to the power 5, which will be 4 by 5 raised to the power 5 into p, which is 1 upon 5, and 1 plus q, 1 plus 4 by 5, which will be nothing but 9 by 5. I'm writing it here only, 9 by 5. Now in the denominator, in the numerator we will be having 9 into 4 raised to the power 5 upon, in the denominator 2 1 and 2 fives are here and 5 are here. 5 plus 2 will be 7. So 5 raised to the power 7. This matches our option number B. 9 into 4 raised to the power 5 upon 5 raised to the power 7. This is how we calculate it. I hope that this question is clear with all of you. Now moving forward to another question. This is one of your PYQs, and it has been asked in twisted language. So pay attention to this one. Here they have said that Here they have said that a person purchases a weekly lottery ticket until he wins the lottery. P is the probability of winning the lottery, then the expected number of weeks required to win the lottery. So let us suppose that this person that we are talking about is has won the lottery. Here we will see that let x be the number of weeks required to win the lotteries. Okay, now probability that x equals to x is nothing but probability that it did not win the lottery up till the xth point. Means it even to at first time it did not win, so I will put dash. Then at second time it did not win, so I will put dash. And up till this happened up till xth, up till xth time it did not win, but it win at the end, which is at x plus 1, right? At x plus 1 time it won. So there will be something, because they have given x equals to x, we cannot take exceeding x. So at x at time it won, and at x till x minus 1 at time it did not win. Suppose x is the fifth time. So at fifth time it won, and before that for first, second, third, and fourth it did not win. So this will be it. But they all are independently distributed. So they can be written as probability of E1 bar into probability of E2 bar, and so on till probability of E x minus 1 bar into probability that it won, which is x. Now all these bars says that it did not win, which is the probability of q up till the time x minus 1, and the probability of failure actually, and that it win, it will be p. Now they have asked the expected number of weeks. Expected number of weeks. Whenever we found the expectation of anything, then it has the formula for discrete random variable. It will be summation x into PMF. Here the PMF has been taken as this only, Px equals to x. So it will be summation of x goes from 0 to up till infinity. We are not writing that. X into px, which will be q raised to the power x minus 1 into p. Now p comes outside of the summation because it is treated as the constant. X raised to the power 0. X goes from 0 to infinity. Let us write infinity only. X into q raised to the power minus x minus 1. So p in the bracket, this will become, if x is equals to 0, it will be 0 plus 1 plus, if it is 2, q plus 3q square, and up till so on till infinity. So as we observe this, then this is nothing but a geometric progression series. And the sum of geometric progression series is nothing. A geometric progression series is nothing. So, sum of a geometric progression series is a upon 1 minus r, where a is the first term and r is the difference. So a is the first term because 0 is not considered as the first term, so first term will be 1, and the difference you can see it will be of q. Everywhere it will be of 1 minus q, 1 minus q. So here it will be a will be 1 upon 1 minus q raised to the power 2, raised to the power n. So if we put it here, if we put it in estimation, then it will be p into 1 upon 1 minus q whole square, which is p upon 1 minus q is nothing but p square, and if we cancel them we will be getting 1 upon p, which is our expected value, which is our option number A. And hence we complete our this was of 2019, they asked us in 2019. So that's all for today's class. I hope that you got whatever we have done today, and this completes our today's topic, which is geometric distribution. And whatever you are facing doubt in any topic, you can ask us in comment section or on our WhatsApp channel. Only relevant doubts will be answered. All the best. Thank you.